A few minutes later.
Jay? What are you doing here?
Just took my MCAT.
You did? Looking like that?
Yeah.
Oh man.
The MCAT's like war, you know, you always gotta be ready for anything. So.
Is that why you're working in the military yet?
Yeah.
Well, it looks like you were pretty prepared, but
Hi. I'm Jay.
Oh, hey, and I'm Zain.
And, today, we're gonna be talking about metabolism and ATP.
Yeah, I was gonna ask you, Jay, because, I've been really struggling with understanding how we can get glucose, but then get, ATP, which is the energy currency of the cell. So you mind breaking down the process for me?
Yeah, so, as you know, ATP's the main energy currency of the cell. It's considered a nucleotide, it's adenosine triphosphate, and the main way that it's used as energy is that since it has three phosphate groups, the last one is cleaved off, essentially, through this process called hydrolysis, in which a water molecule is added to kind of knock off that last phosphate group. And do you know what that does, Dan?
It releases a ton of energy?
Yeah, so that release of energy essentially fuels a lot of the reactions in the cell. You'll have other energy molecules like GTP or whatever, but ATP is the main one you need to know. And glycolysis is a good example of how you make a lot of, or at least start making a lot of ATP. So, glycolysis essentially is this anaerobic, meaning it doesn't require oxygen, process in which glucose is broken down into two pyruvate molecules. So glucose is a 6-carbon molecule, and through a series of steps, you'll have these two pyruvate 3-carbon molecules. So there's 3 phases. There's the energy investment phase.
Okay.
So why do you think it's called the energy investment phase?
Because we're gonna invest some ATP in there.
Correct. So glycolysis has a net total of 2 ATPs gained, and that's because you use 2 ATP in the beginning in the energy investment phase, but you gain 4 ATP. So in the energy investment phase, you're essentially using ATP to make the glucose destabilize, you're isomerizing it into fructose, and eventually you have this second phase called the cleavage phase, where you kind of cleave it into 2 different molecules. Then eventually one of the molecules, DHAP, gets turned into G3P, so you have 2 G3P molecules, and then you finally go on to the third phase, which is the energy output phase. And in that phase essentially, you'll have something called substrate level phosphorylation, which is the creation of ATP through a simple reaction, going from reactant to product.
And this happens in the cytoplasm, yeah?
Correct. All this is happening in the cytoplasm. So, after the energy output phase, you're essentially going to end up with 2 pyruvate molecules, a little bit of ATP, and some of this molecule called NADH, which is a high energy electron carrier, which is important for this process called oxidative phosphorylation, which we'll talk about soon. So you have these 2 pyruvates, they go on to the mitochondria, the powerhouse of the cell, and they get converted into acetyl-CoAs, which are 2 carbon molecules.
And this is in the mitochondrial matrix?
Correct, which is the inside of the mitochondria. Remember, the mitochondria is a 2-membrane structure, it has 2 membranes. So it's going to have the cytosol, the intermembrane space, and the matrix. So those are all separated by membranes, essentially. Now, once you get into the matrix and you make acetyl-CoA, the acetyl-CoA is going to go through this cycle called the citric acid cycle, which is really just a series of reactions. So what happens is, the reason it's called a cycle is because acetyl-CoA is a 2-carbon molecule that combines with oxaloacetate, a 4-carbon molecule, to make citrate. And you don't really need to know the rest of it, but it goes through a huge cycle, and you make some NADH and some ATP, and eventually you go back to oxaloacetate, the starting molecule. So that's why it's called the cycle.
You also create some FADH, right, Jay?
Correct. So FADH, you make NADH, and you also make FADH2, which is another electron carrier. So you've made a little bit of ATP. You made about 2 from glycolysis. You made 1 from each spin of the citric acid cycle. So 2 technically, because you have 2 acetyl-CoAs. You got 4 ATPs. So where do you get the bulk of ATP?
I'm guessing in the electron transfer chain?
Correct. So those electron carriers, NADH and FADH2, those actually go to the mitochondrial membrane, and you have this series of proteins called the electron transport chain, which will accept those electrons from those carriers and pass them along the chain, and eventually they'll hit oxygen, and that'll make water combining with the hydrogen ions in the solution. So you made some water. Now, throughout this whole process, you're doing this thing this thing called proton pumping, where as those electrons are flowing down their gradient or flowing down the chain, you're pumping these protons into the intramembrane space. So why do you think that's important now?
Is it to help create a gradient?
Correct. Remember, things want to move down their gradients, right?
Yeah, exactly.
They want to go from high to low. So you're essentially pumping all those protons into the intramembrane space. So where do you think they will want to go next?
Well, they'll probably want to go back down, right?
Right.
The gradient.
Yeah, and they actually go through this protein called the ATP synthase. And when they do that, these protons all flow down the ATP synthase, you're going to make ATP because you're going to slap on a phosphate onto ADP to make ATP.
So, Jay, it's kind of like blowing up a balloon with air and then letting it go and letting all the air out, right? You fill it up with a bunch of oxygen molecules and then they all want to release out, and it kind of creates that pressure air force that comes out, right?
That's exactly right, Zain. Because once you pump those hydrogen ions in, you can think of it as a balloon because they really want to go back down. And when they do, it'll release a lot of energy, and that's the energy you need to make a lot of ATP. So that process is called oxidative phosphorylation. It makes a lot more ATP than glycolysis and the citric acid cycle. So it makes, for a single glucose molecule, for all the energy carrier molecules you make from a single glucose molecule, you'll get 34 to 38 ATP molecules. That's a lot of ATP.
Wow,
right?
that's a lot of
crazy.
ATP.
You can kind of think of it as like, the owner of a company, or like, the owner of a factory making all the money in the oxidative phosphorylation. And glycolysis and CTA don't really make that much, they're kind of the factory workers.
Oh, okay.
That's a good way to think about it.
No, I think that's a good way.
There's a key thing though. To even have citric acid cycle and the electron transport chain happen, that process, you're gonna need oxygen essentially. So if the cell doesn't have oxygen, you're only going to do glycolysis and repeat that.
Okay, so I know now that I'm looking at it, Jay. So for the MCAT, for glycolysis, I'm going to need to know that it happens in the cytoplasm, right?
Mm-hmm.
It creates 2 NADH, 2 ATP, and 2 pyruvate molecules.
Correct.
And then there's 3 phases: the energy investment, the energy creation, and there's also the splitting phase, right?
Right. So you have the investment, cleavage, and the energy output phase.
Okay, and then what happens next? What do I need to know for the MCAT for
So
the
next thing you
citric acid
know
cycle?
is if there's oxygen, pyruvate will go to the mitochondria and get turned into acetyl-CoA. And as you know, acetyl-CoA goes through that citric acid cycle to make more of those electron transport, high energy electron carriers, NADH, and another one called FADH2, as well as making a little bit of ATP.
Okay, and then finally, the electron transfer chain, right? All these high energy electron carriers are carrying these high energy electrons. They go, kind of down this staircase of the electron transfer chain. Protons are pumped, and then when there's a huge gradient established, they go down the gradient and kind of fuel the creation of ATP, right?
Through ATP synthase, correct.
Okay.
Correct. So,
and that happens in the mitochondria, that happens in the inner membrane space, right?
Mm-hmm.
Okay.
It's kind of an interface between the intermembrane space and the matrix. That's all happening along that membrane, essentially.
And ultimately, the last part of cellular metabolism is aerobic because oxygen is involved as the final electron acceptor, right?
Correct. That's what we call aerobic respiration, because oxygen is the final electron acceptor in that electron transport chain.
All right, awesome. Thanks, Jay. I think I'm feeling much better about cellular metabolism. I think I'm ready.
Mm-hmm. You ready to take the MCAT? You can take my helmet.
Yeah, I will need it, dude. Thank you so much.